Okay, I wanted to add to that previous video. So I wanted to add to the previous video where we talked about R and the binomial distribution. I just want to add, I think a picture would be pretty helpful here. I want to add the following. So the D binomial function, by the way, this is a graph of the binomial distribution with 20 trials where the probability of a success is 1/4. And so we get this graph. Each of these heights is the probability. So the probability of 4 successes is something like that, like 0.18. And so what I want to do is I want to talk about the different commands here. So if I were to talk about, say, the probability of exactly 9 successes given 20 trials, the way that I would do that would be I want to find D binomial of 9, so 9 successes given 20 trials, where the probability of a success is 0.25. Okay, and if we were to type that into R, so if we type that in R, we're going to end up with, so D binomial 920.25 would be 0.0271. So 0.0271. And that looks about right given the picture. Okay, so that looks about right. So that's what the D binomial function is going to do. So this D binomial term is going to give you the height of this bar here. In contrast, the Q binomial, or the P binomial term, I want to just add very quickly that on the Google document and on the R documentation, if you were to use the help button, there's 4 binomial term functions. Q binomial and R binomial, we are not going to use that much. If we need to come back and talk about them, we will. You can ignore them for now. But the P binomial function is going to be the cumulative probability up to and including a certain point. So let's say I wanted to find the probability of 5 or fewer successes. Okay, so if I want to find the probability of 5 or fewer successes, that's the term that I would do. So this is going to represent 5 or fewer successes. So let's do it this way. So it's going to be the height of that line, 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 and the height of that. So it's going to be all those added up. It didn't look as good as I thought it would. So let's go back in color. So it's going to be that height plus 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 that height. And so if we add all of those up, that's going to be the cumulative probability. So this is the probability that our successes are fewer than, less than or equal to 5. So that's what that's going to represent. Okay, and that's much nicer than having to go through and add all of those probabilities individually. Okay, on the other hand, let's do just one more example here. If I wanted to find the probability of having at least 5 successes, there's 2 ways that we could do this. So if I wanted to find the probability of having at least 5 successes, there's 2 ways that we could do it. Let me actually make this just slightly easier. Let me say I want to find the probability of having at least 6 successes. So there's 2 ways that we can do that. The first way is we could do 1 minus P binomial of 5 or fewer successes, because the complement of at least 6 is 5 or fewer. Or you could actually do one other thing. You could do P binomial, so you could also write this as P binomial of 6, 20.25, except you have to add 1 bit of code. And the code is, we're going to switch from talking about the lower tail to the upper tail. So the lower tail is false. And what that does is, instead of thinking about the cumulative probability, what it's going to do is it's going to think about the probability for this point afterwards. So it'll take the sum of all those probabilities. That's what this lower tail equals false code is going to be. And again, you can read more about that in the R documentation.